Hey everyone, on this lesson we will work with the dimensionality reduction using the principal component analysis technique in Python. So, on this lesson we are given a data set and we will apply here a dimensionality reduction. This is the transformation of the data from a high dimensional space into a low dimensional space, returning the information of the data set. So we reduce the dimensions and we also retain and maintain this information. So the technique that we will use on this lesson is the principal component analysis. Also, the name of this data frame and data set is grabs, as it is a CSV file. You can download this file grabs.csv on the downloadable documents of this lesson. So first of all, let's introduce this data set. Campbell studied rock crabs in the genus Leptograpsus in 1974. You can look and search for this article. There's an article that has been published by Campbell. He was a researcher that studied rock crabs. One species, the Leptograpsus variegatus, had split into two new species, previously grouped by color, orange and blue. Preserved specimens lose their color, so it was hoped and expected that the morphological differences will allow the museum material to be classified. So here is where the data set comes, the data, and all the data are available on 50 specimens of each sex of each species, so we will have 200 in total collected in Fremantle, Western Australia. And now this is very important because it is where we have the features, where we have the attributes of this data set. So here it mentions each specimen has measurements on first the frontal lobe width, abbreviated with FL, then we have the rear width, abbreviated with RW, the length along the midline of the carapace, that is abbreviated with CO, the maximum width of the carapace with CW, and the depth body length with BD in millimeters. Also, we have the color of this crab. This is also, in other words, the species of the crab, and finally the sex of this crab. Very well, so now let's create a new notebook in Google Colab to start working. Very well, we have created this new Google Colab notebook. We already explained on previous lessons how to create a new Google Colab file to start working in Python. So the name of this notebook is PCA in the grabs data set, since we will apply the principal component analysis technique. So the first thing, we will create here a text window where we will have here all the imports. So here let's just mention this is going to be the import of libraries that we will need to import in this notebook, and here we can just add the code window, okay, just after. And here we will start importing all the libraries. So also let's make this text a bit smaller with this header here. Remember, when you write a hashtag, you have title 1. If you write 2 hashtags, we have the title 2 notation. 3 hashtags, the title 3. So we want to import this CSV file. We want to import this data set. And so we will import it as a pandas data set. So the first thing that we need to do is to import the pandas library. In Python, we do it in this way: import pandas as PD, okay? Pandas is a software library written for the Python programming language for data manipulation and analysis. We will use this library a lot along this course. Now, since we want to read a CSV file, we need to be able to read files from our computer. To do so, we need to import here, first of all, the input and output library in Python. This is the IO library. And also, Since we're working in Google Colab, we need to make an import from the Google Colab. We will import all the files that we will update. So here we import all the files. So as we can see here, we have a files folder that if we click on it, we can see all the files that we have loaded inside this notebook. We really have nothing inside. We only have the default sample data that this environment for Google Colab provides, right? So we will use our own CSV. So we will create now a new code window, and inside this window, we will upload some files. So here we will say, all right, uploaded is going to be files, and we will use the method upload, like so. So with this, when we run this cell, we will upload the files that we want from our computer. So in our environment, you should first download this dataset grabs.csv. You download it. Once you have on your computer, then you load it on the notebook, right? So here, in order, let's first import all these libraries, and this cell is already executed. So now we press here the play button. So we run this cell. Now, as we can see, we have an option that is choose file. So we click on it. Then you look for this file in your computer. So we just come here and we press the grabs dataset. This is the dataset that we will use on this lesson, and we just double click on it or just open. And as we can see, this dataset grabs.csv is already saved inside our folder files in the Google Colab notebook. So if we open this folder, we can see here now we have loaded this dataset grabs.csv. Very well. We will now read this CSV as a pandas data frame. So we just add a new code window. And here we will define the name of this data set, for instance, grabs data. You can define here any name. You can just write grabs, okay? We will use here the name and the notation grabs data. So to read the CSV using pandas library, we just need to use here PD, which is to access the pandas library and all the methods of this library provides. Then we write a point, a period, and here we write the method read CSV. And now we pass as the argument just the name of this file. In our case, it is grabs.csv. So very important. Here you pass the name that you have inside this folder. This folder, the name of this CSV is grabs.csv. So here we pass the same name. So now we run this. And now we have inside this variable in Python, this grabs data, we have the data set. And we can verify this. For instance, if we have a pandas data set or a pandas data frame, and we want to see the first rows of this data set, okay, we can just press the method head. Okay, with this, we will visualize the first rows of this data set. So as we can see, we are able to see and observe the first 5 rows, the first 5 grabs and 5 instances of this data set. And we have here all the columns. We have a column for the species, the column for sex, the column for the index, okay. This is also the identifier. Then we have these measurements. Remember that with the eval, this is the abbreviation for the frontal lobe width. This attribute and this feature RW represents the rear width. Then we have here the CL. This is the length along the midline of the carapace of the grab. We also have the attribute CW. This is the maximum width of the carapace. And this final feature BD represents the depth body length in millimeters. So very well, once we have this data set, and before applying any dimensionality reduction technique, we will transform a little this data set and the representation of the columns so that it is easier to see and which columns we have and how we represent these columns. So first of all, we will rename all of these columns. Instead of SP, we will have a species, for instance. Instead of FL, we will have the frontal lobe, and so on. So to do this, with the pandas dataset, we just write the name of this dataset. In this case, the name of this variable that represents the dataset is grabs data. And now we will update this data set to be the original one with the rename of the columns. So what we're going to rename inside this data set are the columns. And here we will substitute, let's use here the equal notation, and we will start with the first column, which has the value of SP, and we'll rename this column SP to be species, like so. Then sex is a column that we will not change because the name is already abbreviated, the same for the index, but here the FL, we will change this FL, so the FL column is going to be replaced for the frontal lobe. So here we will have frontal lobe. The same applies for the RW, right? This is the rear width, so we just write rear width. Then we continue with the CL. Remember that this attribute here, this feature CL, represents the carapace midline. So here we will rename the CL column for carapace midline. Then the CW column to be the maximum width of the carapace. Remember that CW, this feature, is the maximum width of the carapace. So here we have that CW is going to be the maximum width for the carapace. And finally, we only have this BD. So here we will rename this feature BD to be the body depth, right? This BD is the depth body length in millimeters. So here we will have the body depth in millimeters. So here we just write body depth like so. Very well. And once we apply this data rename, okay, and once we run this instruction, then the data set is going to be updated and the column's name will be changed. So let's verify this. So let's run this cell. So once we have run this cell, let's now run this instruction to get the first 5 rows of this data set. So let's see how the data set is now. We press this run button, and as we can see, the data set has been updated, right? The names for the columns have been updated. We only changed the names, okay? All the values are the same. So here we also see 2 particular things. We see here a categorical variable, which is the species, and also this categorical variable, which is the sex. And B represents and stands for blue. And then you can also see at the end that we have another type of grab, which is the orange grab. So in fact, here, if we write as an argument 10, we'll have the first 10 values, right? It seems that all of them are blue, so instead of head, we will use tail to check the last ones of this data set. So if we run this, we see the last 5 elements of this data set, right? And these last 5 elements, we see that here in the species, we have a value of O. So here, O stands for orange and B stands for blue. The same happens with the sex. It is a categorical binary possible value. F is for female and M is for male, right? If we just look the first 5 elements, we see here that they are male. So we have here F or M in sex, and also we have the options B or the letter O in species. So what we will do to continue transforming this data set for better visualization and then applying the dimensionality reduction with the PCA technique is we will map each value B for being blue and each value O to be orange, and in the same way in the sex attribute we will map each value M to be male and each value F to be female. So to do this in pandas, we do it in the following way. So first of all here, okay, we will access this column species, so we can do this with grab data species. We will modify this column and we will say, all right, we will apply a mapping such that for each value B, transform this value and map this value to be blue, and for each value F, or in this case O, map this value to be orange. So here we will access again this column species, and we will map this value depending if we have a B. So if we have a B in here, we'll map this to be blue, right? If we have an O, we will map this O to be an orange, like so. Keep in mind that this is different from what we have done before, right? Also here we need to include this list, so let's include this list in here. In this case a dictionary, this is not a list, but regard a dictionary. So this is different from what we've done before, because before what we changed were the names for the attributes, the name for the columns. Here what we are changing are the values, okay, inside a given column. So if we need to change the values inside this data set, we need to apply a mapping process, okay? So what pandas will do and what Python will do is, for each value b that he finds inside the column of species, it will substitute this b to be blue, and for each value o, it will substitute this o to be orange. And we will do the same in the sex feature. So here we will access the sex, we'll modify this column. This is going to be grabs data sex, and now we are going to map all the values that we find m to be male, and all the values that we find f to be female, right? Like so. So we are applying also the same mapping process, right? So let's run this and see how this data set is updated. We come here, we press the run cell, and before pressing this cell, remember that here we have a dictionary, so we need to add here the braces, like so. So now we run this cell. And now let's see how this is updated. So here in this code window, we will apply the same thing, grabs data head. We will execute now this window. And now as we can see, for each value that before was B, we have blue, and for each value that before was M, we have male. In the same way, if we look at the last elements of this data set, we have here that for each value O, we have orange, for each value F, we have female. In fact, we can see more details and study more this data set. We can check for the description of this data set using all the columns. So to do this, we just write the name of this data set. Then we use the method describe, and here we will include all the features. So here we will include all and all the data set, right? Include all. So let's press run. And as we can see, we have this description of the whole data set. In the sense of, so as we can see many informations, we can see the count of how many values we have, right? Keep in mind that since the data set and on this environment, they say we have a total of 200 species, we have 200 grabs, different grabs, 200 instances, so we will have 200 rows in this data set, right? This is an account, this is the account for the unique values, the mean, we have many here descriptions, right, for each attribute. So as we can see, the precision sometimes is very big, so we don't want this very high precision, so we can reduce this in the pandas configuration. So here, just above the pandas, we can change the precision of the display, so we can just write PD. We use here the set option method, set option, and here we will set the precision, so display precision to be, for instance, 3. So here we will just change this to be 3. So we run now this cell, we update the code, and now when we do the same thing here, we see that we have this precision only with 3 decimal values. Okay, this is because we don't want this very high precision. Very well. We can also check the columns. Here, if we write a new code window, for instance, grabs data columns, here we can visualize all the columns on this data set. Right, we have species, sex, index, frontal lobe, rear width, and so on. Also, a very important method that is very important to visualize is the shape, because here we can see how many rows in total and how many columns we have in this data set. So here if we just write grabs data shape, we see that we have a total of 200 rows and 8 columns, right? For instance, in here grabs data head, okay, we can see the first 5 rows, but we have actually in total 200 rows, okay, and 8 columns, the column for species, sex, index, frontal lobe, rear width, carapace, midline, maximum width, and body depth, a total of 8 rows. So keep in mind that this first row is the identifier row, so this is not really a attribute, neither a feature in the pandas data frame. This is only for specifying which grab instance we're dealing with at this moment. Okay, the attributes are 8 and they are these ones. So the objective in this data set is to separate the 200 grabs that we have into 4 classes given by the configurations for sex and species. So we will have 4 classes, right? One for male blue, another for male orange, and then another for female blue, and another finally for female orange. So here first, let's add the new text window to indicate that this is the goal, right? And to separate these classes, okay, here in the pandas data frame, we will create a new column for the class. So here grabs data, let's create a new column. This is going to be the name class. Okay, you can write here any name, we will use the name class. And this is going to be the concatenation for the grabs data species plus the grabs data sex. So we will have a class column that will be the concatenation of the species and sex. Right, we can also here visualize how many different classes we will have at the end. Well, in this case we will have 4, so how many of each we will have. So here we just write grabs data class, and we can access how many values and different values of this column we have with the value counts. Okay, so here if we just run this, we see that we have the same amount of each class. We have 50 grabs that are blue male, 50 grabs that are blue female, 51 that are orange male, and 51 that are orange female. In fact, right here, if we just again check for the first rows of this data set, now we'll see an extra column. Okay, we have now the column class that is basically the concatenation of the species and the sex. Since this grab with identifier 0 is blue and male, we have that he belongs to the class blue male. In the same here for the next one. If we check the last ones, we see that since this grab is orange and female, right, we see that it belongs to the class orange female. Very well, once we have these classes separated, we have this exercise. Visualize all the classes that we have on this data set, and also improve the visualization applying the dimensionality reduction technique that is the principal component analysis. And this is what we will do on the following lessons. On this lesson, we introduce this grabs data set. We also study this data set, right? And transform this data set for better description. And on the following lessons, we will visualize this data set and apply the dimensionality reduction PCA technique to have a better visualization. We remember that you can download all the documentation as well as all this notebook and this code on the downloadable documents of this lesson. See you on the next lesson.